In this presentation, we are going to find the primitive roots. As usual, let's start the session with the outcomes. Upon the completion of this session, the learner will be able to, outcome number 1, we will know about primitive roots of prime number, and outcome number 2, we are going to determine whether a number is a primitive root of a given prime number or not. So in the coming lectures, we are going to see the Diffie-Hellman key exchange process. There we need the concept of primitive roots, and that's why I am providing the fundamentals here itself. So keep track of this lecture. It will be really helpful for us to solve the problems when we see the Diffie-Hellman key exchange algorithm and problems. Why waiting? Let's see what is a primitive root. Let's see the definition now. A number alpha is said to be a primitive root modulo n if every number coprime to n is congruent to a power of alpha mod n. I know the definition seems to be intricate, but I have made the definition easy for you. So let's see the easiest way of saying this. Alpha is said to be a primitive root of a prime number p. So we have a prime number p, and when we will say this alpha is said to be a primitive root of the prime number p, if alpha power 1 mod p, alpha power 2 mod p, alpha power 3 mod p up to alpha power p minus 1 mod p are distinct. For example, if we are saying a prime number 5, and if we take alpha is equal to 2, so 2 power 1 mod 5, 2 power 2 mod 5, 2 power 3 mod 5, up to 2 power 5 minus 1, that is 2 power 4 mod 5, all are distinct. Then alpha is said to be a primitive root of the prime number p. Anyway, we are going to understand this when we see the examples. Let's directly step into example number 1. The question is 2 a primitive root of prime number 5? Here, two important data are given to us. One is the prime number and the other one is 2. So we are required to check whether 2 is a primitive root of the prime number 5. So let's solve this now. So we are going to take 2 power 1 mod 5, 2 power 2 mod 5 up to 2 power 4 mod 5, right? So we are going to solve 2 power 1 mod 5, 2 power 2 mod 5, 2 power 3 mod 5 and 2 power 4 mod 5. And we are going to stop only up to this y, because we are going to stop this up to 2 power 5 minus 1, that is p minus 1. This is what we have seen in the definition. Let's simplify this now. 2 power 1 mod 5 is what? 2 mod 5. Let's come to this. What is 2 power 2 mod 5? 2 power 2 is 4 mod 5, right? So here we get 4 mod 5, here we get 8 mod 5 and here we get 16 mod 5. Let's simplify this. 2 mod 5, 2 when it is divided by 5, obviously 2 is the remainder, right? So we get 2 as the remainder here. So we get 4 as the remainder here. We get 3 as the remainder here. Why? 8 when it is divided by 3, 5 1 times 5 and the remainder will be obviously 3. And 16 when it is divided by 5, we get 1 as the remainder. As per the definition, alpha power 1 mod p, alpha power 2 mod p up to alpha power p minus 1 mod p should give distinct values, right? Or it should be uniformly distributed, right? When you take this prime number 5, what are all the positive numbers less than 5? It's 1, 2, 3, 4. Are these values uniformly distributed or distinct? Yes, we can see 2, 4, 3, 1, all are distinct values which are uniformly distributed. So 2 is a primitive root of the number 5. So in the question we are asked to find, is 2 a primitive root of the prime number 5? So the answer is yes, 2 is a primitive root of prime number 5. I hope things are clear to you. Let's step into example number 2. In example number 2, we are required to find is 3 a primitive root of prime number 7. Let's solve this now. We know what we are going to do. We are going to check 3 power 1 mod 7, 3 power 2 mod 7 up to 3 power 6 mod 7, right? So we are going to find 3 power 1 mod 7, 3 power 2 mod 7, 3 power 3 mod 7, 3 power 4 mod 7, 3 power 5 mod 7 and 3 power 6 mod 7. Let's simplify this. What is 3 power 1 mod 7? Which is 3 mod 7. When you simplify 3 mod 7, we get 3 as the remainder. Let's move on to the next one. 3 power 2 mod 7, 3 square is what? 9. So 9 mod 7, when you simplify this, we get 2 as the result. What is 3 power 3? So 3 power 3 can be 3 power 2 into 3 power 1, isn't it? We got 3 power 2, which is 2. We got 3 power 1, which is 3. So 3 power 3 can be 2 into 3, right? So 2 into 3 is 6. So we get 6 mod 7. So 6 mod 7 means the remainder is 6. Let's take 3 power 4. 3 power 4 can be written as 3 power 3 into 3 power 1, right? So 3 power 3 is 6. 3 power 1 is 3. So 6 into 3 is 18. So 18 mod 7, we get the remainder as 4. 3 power 5 can be 3 power 4 into 3 power 1. 3 power 4 is 4. 3 power 1 is 3. So 4 into 3 is 12. 12 mod 7 is 5. And finally, we get 3 power 6. 3 power 6 can be 3 power 5 into 3 power 1, right? So 3 power 5 is 5. 3 power 1 is 3. So 5 into 3 is 15. So 15 mod 7 will give 1 as the remainder. Are the results distinct? In other words, are the values uniformly distributed? In simple words, are you getting values exactly once? Yes, 3, 2, 6, 4, 5, 1 are appearing only once, or uniformly distributed, or they are distinct. So the answer for this question is yes, 3 is a primitive root of number 7. Let's see the last example. The question is 2 a primitive root of number 7? Now we got the idea of solving this, right? We know we are going to find 2 power 1 mod 7, 2 power 2 mod 7 up to 2 power 6 mod 7. We can easily simplify this. 2 power 1 mod 7 is 2 mod 7. 2 mod 7 is simply 2. 2 power 2 mod 7 is 4 mod 7, which is simply 4. 2 power 3 is 8 mod 7, which is simply 1. 2 power 4 is 16 mod 7, which is simply 2. Can you see here? This 2 is appearing one more time. Are we getting distinct values? No. You can stop up to this and you can say that 2 is not a primitive root of prime number 7. But still we will verify this. Let's proceed with 2 power 5 mod 7. So which is 32 mod 7. 32 when it is divided by 7 we get 4 mod 7 or simply 4. Then we'll simplify 2 power 6 mod 7. 2 power 6 can be 2 power 5 into 2 power 1 or 2 power 4 into 2 power 2 or 2 power 3 into 2 power 3. So whatever approach you take, ensure that you are doing the right calculations. So anyway, when you simplify 2 power 6 mod 7, you get 8 mod 7. 8 when it is divided by 7, we get 1 as the remainder. Are you getting the distinct values? 2, yes. 4, yes. 1, yes. And henceforth, we are not getting distinct values. And also, the results are not uniformly distributed, isn't it? So what's the question? Is 2 a primitive root of prime number 7? The answer is no. 2 is not a primitive root of prime number 7. Before we step out of this lecture, let's see the homework question for you. I have given 2 questions. Let's see the first question. The question is 2 a primitive root of prime number 11? So you are required to find 2 power 1 mod 11, 2 power 2 mod 11 up to 2 power 10 mod 11. And if you get the distinct values, then you can confirm 2 is a primitive root of number 11. And question number 2 is, it's a different question. Can you see here? What are the primitive roots of prime number 5? It's not you are going to verify whether the given number is a primitive root or not. You are going to find out what are all the numbers that are primitive root for this prime number 5. So if you want, I can give you a hint for you. The hint is you can take like this. What are all the positive numbers that are less than 5? It's 1, 2, 3 and 4, right? We can ignore this 1 because 1 power anything will always be 1. So 1 power any positive number will always be 1. So this will not give distinct values or unique values. So let's ignore this. You just ensure with 2, 3 and 4. And already we have solved this in example number 1. We confirm that 2 is a primitive root. Try verifying is 3 a primitive root and 4 a primitive root. So using this hint, I hope you can solve question number 2 also. After solving this, I request you to post your answers in the comment section. And that's it guys. I hope now you understood what is a primitive root of a prime number, and we also have determined whether a number is a primitive root of a given prime number or not. I hope the session is informative and thank you for watching.